Hey, welcome everyone. Well, finally we start on time. Thanks for coming to Hoofddorp to attend this SaKE. Also the people watching the stream, welcome. I think we have a great agenda for today with a whole variety of talks. So let's not waste too much time listening to me, but go directly to the wonderful content we have. And we start off with, well, at least 50% internal speaker, which is nice. And we love internal speakers, by the way. So if you have something interesting to share from your daily work, do reach out to Jelmer or me, and we can get you on the agenda for the next episode. But you're part of the new team, a special squad that started just for rebuilding Nu. And you rebuilt Nu Sport in just 2 months using this technology. So we're dying to hear what you are going to tell about that. So please give a round of applause for Johnny and Emiel.
Did you? Okay, nice. So welcome everybody. We're going to tell you something about Firebase, how we were using it in Nu Sport. My name is Johnny Mijnhout, and I'm working in the Nu Sport team as a Python developer.
My name is Emiel, the second one on the list, and I'm an iOS developer, also part of the same team for Nu Sport.
Okay, so we'll start out with how we first encountered Firebase and we started using it. We were asked to create a new Nu Sport app. The old one was mostly article-based. And the new one had some new requirements. As you can see here, they wanted to have a timeline where the editors can add new content and it should be displayed immediately to all clients. So it should be all real time and should be to mobile and web, etc. And we had another one, our deadline was 2 months because some important soccer matches were coming up and we had to do it before time. So, with this in mind, we had some options. We could use the current third-party software we're using for NuNL. We have a timeline inside it. And the third-party software isn't using WebSockets, and we're stuck to them. They're planning if we want custom content, especially for Nu Sport, we want scoreboards which automatically update. So that will be pretty tricky to have them built by an external party. Another option we have was to build it our own, but we would have to make our own backend, our own CMS, and our own clients, and we still have that deadline of 2 months, so that would be pretty tricky to manage that. So we found a third option, and it was to use Firebase. So now you're asking, what is Firebase? Well, actually, Firebase started as a real-time database. It currently has a lot more components, which we will show you in a minute. The real-time database means it's a database, and as soon as you change data in it, it will automatically push to all clients, mobile, web, etc., instantly. So that's exactly what we were needing for Nu Sport. Firebase started as in a small company who created this, and it was acquired by Google in 2014, and Google is now adding more components to it. As you can see here, these are the components we're currently using and the ones we will be discussing during this presentation. These are the components we're not currently using, currently not because we will be. I can say something about them very quickly. There's the storage component, which is actually used for storing static data like images, videos, and documents your users want to upload, for example. It's accessible through an API. Then there's hosting. It's hosting of static assets. So you can host your HTML, CSS, and your JavaScript. And with the current JavaScript frameworks, you can create your complete application using Firebase as your backend. Then there's the test lab, which is currently only for Android. You can connect your app to the test lab, and you can write your own test for it, but the test lab also has an option to test the app for you. So it will try to find all edge cases inside your app and generate crashes, which can be pretty great. Then there's the notifications component. Google Cloud Messaging used to be the notification server for Google. They're currently switching to the Firebase Cloud Messaging. Google Cloud Messaging isn't deprecated yet, but they're not creating new features for them. So if you're using Google Cloud Messaging, you are encouraged to switch to Firebase Cloud Messaging.
And the nice part of notification also, to extend something, is that it's always also supporting for iOS. So it's not only Android, but it's also an iOS.
And also for web, if your browser supports it. So, and finally, there's dynamic links, which allows you to link directly inside your app, which is not something new. What is new is if your clients don't have the app installed yet, you can give them a dynamic link. The app will be installed, and after the app is installed, you can redirect the user to the link he wanted to go to. So the link is not lost during the installment. So now we're getting to the real-time database we're using. You can see here the structure we are using for Nieuwsport. It's actually a NoSQL database. It's one big JSON object. You can put JSON inside it and you can read from it. It's a NoSQL database, so you can't make any connections to other trees for your data, etc. So that's one thing. You have to make sure that your data is as flat as possible. And for filtering, it's also pretty limited. You can filter on a child property. For example, give me all blocks which have is protected is false or true. And that's it. If you also want them to filter on pinned, it's a combination, and that isn't even possible. So you need to make sure that your data structure is already prepared for that. Secondly, sorting and priority. All data is sorted if you don't give a priority by the key from low to higher. But you can also set a priority flag, which is an integer, and it can be negative, can be positive. We wanted our data to have the most recent article on top. So we're using a negative timestamp to make sure that when a new article enters, the timestamp will be higher, but we make it negative, so it will appear on top of the previous one. Finally, there's the authentication. You can make authentication on a lot of levels. We do the authentication on a root level, and we just say all our clients have read rights, and our server has as the only writing right. But you can also use Facebook or other social media clients, which are also built inside Firebase. So you can nest your authentication inside your tree. So you can replace this with your Facebook ID, for example, and then you can say, well, you need to log in with your Facebook account, and then you can write to your own piece of JSON. So that. Here we have an example of the JavaScript client. This config part is actually generated by Firebase. So when you're inside your Firebase application, you can say, I want to create a new web app, and then it generates this part of code. And then you can add your own listeners to it. This is a very brief example. Here you can see I make a reference to this endpoint, all live, which you can see on the previous slide. This is all live, so all blocks below live, all updates will appear in my subscription. And here you can see the functions child added, child changed, child removed, and child moved. Every function gets a snap. So as soon as the child is added, you can retrieve the key of it, which is this one, and this one, and this one, and this one. And you can fetch the value, which is actually the JSON inside your object. And you also get the previous child, and this can be handy for the child moved event, because when your priority has changed, your child will be moved because the order has changed. And if you want to show that on your clients, you will need to know where in the tree do I need to position this new client. So by getting the previous child key, you know where to put it inside your client.
So that looked like really easy.
Yes, it is.
And now for something more complex, because we had some other requirements. Our timeline was not like when there is a post on a timeline, it will never change anymore. So when you have a static timeline, it's much easier to query your data. But when you have like a dynamic timeline, every time each block can be altered, can be deleted, and there could be new blocks that appear. So we came up with the following solution. We do a first query, which only queries like the top items. So the first page of your, in case of an app, the first page is like rendered really fast. We got them limited to the first 10. The event type Firebase uses is value. And value means I give you the whole bunch, so the whole 10 or 100 or whatever you want. There's a specific query you can do. The second query, after the first is rendered, is the same ordering by priority, but that is limited to, in this case, 200. And it is like listening on every possible event except the value. So child added, child removed, child changed, and child moved. And that was the code that you saw also previous year. Hey, child changed, child removed, child added. The numbers, like limited to first and limited to first 200, are a remote configuration. So also Firebase, and we come to that in the next sheets, has the possibility to have remote config to manage that. So we were not. Sorry. Should I start over? We were not sure if 200 was enough or was like too much. So we made that a remote config, and we come to that in a second. And I think now it's like demo time.
Yes.
Hammer time. Yeah.
Demo time. So here you can see, maybe you can point them out, Emiel. The content management system.
That's this one?
Exactly.
So it's our own CMS.
Yeah. And we've got the Firebase database, and we've got the new sport app here running on an iOS device. And as you can see here, I've added 3 blocks inside our CMS. I can add a new block here. And you will see it appear here inside the Firebase database, and you will see it inside the app, I hope. So you saw this getting green.
And it's not appearing in the app.
And it's not appearing in the app, of course. No.
Let me restart the app.
Yes.
Is there connection enough?
It should be. So maybe you can sing a song in the meantime.
No, somehow the connection is gone.
No.
Yeah, really?
No, you're kidding.
Didn't you try it out before? We did, extensively.
This is the first time I opened this app.
Oh,
Okay,
that's a shame.
so
That's bad.
yeah, this was working. Okay, but I can show you with the Firebase database. You saw it adding here as number 177. Once I delete it here, yes, confirm. You can see it being deleted inside Firebase here too.
It is working on my app though. So.
Of course it's working on your machine, you build it. So now we can see all Emiel's photos. And let's skip this one and let's try. Dit gaat niet werken volgens mij. Hè? Ah, we prepared this very good and it was always working, but you'll see. Ah, maybe now. Hey, I know that guy. I don't want Emiel's photos. So, Emiel, you're telling us that this is working.
Let's hope.
Hello. Submit. Hey.
Well, there it is.
So,
We're
okay.
not fired, Johnny?
Yeah. Firebase. So, I added this block here saying hello, and I can also edit it. Hello, everyone. And I submit it. And you can see it automatically updates. I can also change the date. And you will see it move down. Bloop. And now it's moved here at the bottom. And finally, I can remove it like this. And it's gone. So you'll see here the database is updated through our CMS. What I can also do, we have this poll block here where people can vote. And as soon as I change the option here, saying this is not active anymore, it will show the results. And people can see what has been voted, and we can also re-enable a poll so people can start voting again. And you can also see as soon as I change, and this is the image, the text here, you can also edit directly inside Firebase. So when I remove it here, you can see it changes here. So that's a quick demo of our new sport app.
Yeah, for now we can continue like another component of the Firebase platform, which is crash reporting. Now, there's nothing really special about the crash reporting Firebase gives us. One thing is, though, that you can add events, the analytics events that precede the crash. So you get a lot of more context, and the developers in this will acknowledge that finding a crash, finding where it happened, finding which use case led to the crash it can be very hard. So this is a nice thing that will going to be in the Firebase crash reporting. One thing we all of our app developers want is measure the success of our app. So there's this analytics for. The analytics for Firebase is unlimited, so it's free. It's up to 500 different types of events. So there are two nice features for the analytics. It is the first one is audience segmentation. So based on your analytics, you can define audiences, and those are dynamic. So you can when you define your audiences, you can use it in other situations, and we will come back in the next sheet on this. And also conversion events, because the main thing we want to know is when is our app really a success. So a selection of 10 events can be defined as conversion events. So when you're having like a new feature, or you have a push message, or you had AdWords, or you had whatever thing going on, you can measure if those conversions are in a good way. It is like tracking your KPIs. So it's really nice. We already talked about the remote config. It's nice to have. The key capabilities are conditionally assigned values, so that's not static values, but you can define it based on your user, based on audiences, which is really nice. It's poll-based, so it's not real-time. So instead of the database, which is real-time, so you should expect that the remote config is also real-time, which is not. So mind that. And when you can use this, so this is really nice when you have behavior in your app you want to enable without releasing a new version. Or if you have custom, you want to customize some UI for different audiences. So here's also the audiences. Audience is not like a specific thing, it's part of the analytics, but you can use it in every way. So when you have defined a specific audience, maybe a gender, maybe a location, maybe based on how many times the user is using your app, you can define also custom UI, or maybe even custom features. And the other thing is roll out new features gradually. So you can say, okay, 10% of our users only gets this version of this feature. So remote config is also very handy. A/B testing is an example of how those components can work together. So it's just an example. We have the Firebase with analytics, and we have the remote config. Analytics, you see, has like multiple parts, audiences, user properties, and events are taking place here. And we got a remote config. You can define an audience. In this case, there's a green audience and a red audience. You got a user property, which is the button color, like the call to action button, maybe. And you want to try out if the green and the red one is better. You also define a remote configuration, which is button color. In this case, we divide the colors evenly on every user. But you can do it in every way you want. It's also dynamic. So the remote config is dynamic. We do it on a percentage based, but it could also be a location based, or it could also be device based. So with people with different devices and different colors. What is happening now is that the client, the app, or the website is getting the button color from the remote config. It's sending the button color as a user property with every event, with every analytics event. And in the analytics, you can then say, okay, this client belongs to the green or belongs to the red audience. The only thing that's limiting is the Firebase UI, which is not very good in reporting. So Google has there something other in place. Like Firebase is most of the time free, and there you have BigQuery, which is like a reporting tool based on the raw data of your analytics, but that is paid. So, and I talked to Paul, which has really tested this out, and it's not very easy to do it with Firebase only.
So now you're probably wondering, well, that's a huge package. That will be a lot of money to get that. Well, actually, Firebase is free. Nice. Well, actually, it's not completely free. So here you'll see a summary of the subscriptions you can get. Spark is the one you get by default, which is free. You can get the Flame subscription, which is limited to some limits. And then you have the Blaze, which is unlimited, and you'll pay as you go. One thing to keep in mind is the simultaneous connections for the Realtime Database, because you will hit this probably when your website is a bit large. These are simultaneous connections, so they're concurrent. So if you have 1,000 users, it doesn't mean you'll have 100 concurrent connections. For Nu Sport, we topped at about 4,000 concurrent connections, but Daan proved that Nu.nl will reach the 10,000 connections. For Nu.nl, because it says here unlimited with a tiny one next to it, and the one says the limit is 10,000. But you can ask Google, and they'll send you a form, and you'll have to answer some questions. What's your application? How many users do you expect, etc., etc. And probably you have no idea how many users you will have concurrent. So you'll just say, I have 2,000 concurrent connections, or 2 million, or something. And then they'll monitor it as soon as your app goes live. And then you can see in the statistics of Firebase what the actually limit was. When we went live, we used the Blaze plan because we had no idea what was going to happen. And we used Serge's credit card, so that wasn't really a problem for us. we used about 400 gigabytes in the first month, and it's $1 per gigabyte. So that's pricing. And finally, things we noticed while we're working with Firebase. One tricky thing is that it tends to convert digs that look like arrays to arrays. So when your index is a number, an integer, and it's sequent, then it will try to create an array for it, and you'll get an array back from it, so you won't have any keys left. You can prevent this by using strings instead of integers as your keys. then it won't do this conversion. And you can see as soon as there's a gap between them, it will give back the data as you put it inside database. But this is something to look out for. Then there's the thing I just mentioned. We used 400 gigabytes. Updates are always pushed, so we were updating the scoreboard every 30 seconds without checking if there actually was an update. So all our clients were getting new updates every 30 seconds, and that can lead up to a lot of data. So you'll need to check for yourself if data has been changed and only then push it to Firebase. Which is also tricky because the Firebase console doesn't show updates like you saw something went green and something went yellow, etc. When nothing has changed, you won't see any changes, but it is pushing everything to your clients. And that means that the database network traffic can become quite high. So keep that in mind. Final thing.
Yeah, the latest one, if you find your traffic is too high and want to search how that is happening, it's hard to debug. So it's like a black box, the SDK of Firebase, because it's using sockets under the hood. So it's not like tracing down a RESTful call and see how many data is transferred. So that can be a hard thing to do.
So that's it. Time for questions.
Paul, do you start setting up? Question? We have. One sec.
Yeah, there's a real-time update. How does the real-time update go when you have really high loads of traffic? Like thousands of users at the same time?
Yeah, all is arranged at Google. Twitch is one user using Firebase for their messages, and they're using millions of messages. So the scalability is at Google at this time.
Like for example, the push messages, Facebook is using it in their products, and big Alibaba, the big Chinese websites, also using push messages. So scalability is like below a second, they say. We asked them, we were in Berlin, and we asked them, and scalability is no issue at all, even with push messages.
Other question? No final question?
Yeah, the billing, you were talking about it. Is it really like only the data, the transfer data? Because I saw some other...
No, there. I don't know where my clicker has gone. Oh, there.
Well, it's storage and data transfer. So, but the expensive part is the data transfer. They bill like $1 for every gigabyte, and that's their business model. So they like you to do a lot of data.
For you it was $400.
Without optimizing.
Yeah.
So we did some strange things, and we are optimizing it right now.
Yeah, and we didn't use these components right now because all components are free, which is mentioned there, and these components are paid. So yeah, it's just a matter of how many data you're using. So for us it was 400.
But this is just new sport?
Yeah.
So if the next is new .nl?
Yes, your credit card will blow.
I'll better check my credit.
Yes. Yeah, we'll need to check. We have some experience in the data traffic right now, in the updates, etc., etc. Yeah. Okay. So.
And the thing you need to calculate is to do it by your own, this kind of thing. So if real time is really a requirement for you, this is not this is more cheap than do it your own. And the scalability is like huge.
Okay, thank you. Give a round of applause for Emiel and Sonny. And for our next speaker, it's a returning speaker because we really loved his talk. For I think almost a year ago, when he was hacking, doing live hacking of passwords here, and switch off your Wi-Fi. Yeah,